Hi, kids. Okay, hey, here's what we're gonna do. I'm gonna go over some basic stuff about circular motion with you guys, so make sure you guys understand. So there's just kind of like some basic terminology stuff you guys need to know, some basic stuff with that. So I have three terms written here: frequency, period, and linear speed. Later on, you guys will learn about angular speed, but for right now, we'll leave it as just linear speed. But if you guys take a look at this, again, don't memorize stuff. So like, if you think about the word frequency, it's called frequency. Why? Because we're talking about how frequent something happens. So if you have something like this where you make 10 revolutions in, I don't know, 4 seconds. I'm just making up some numbers here. Okay? So like, if this is, hey, if I make 10 revolutions in 4 seconds, how frequent is a revolution happening? So it would be like, well, I'm going to get 10 revolutions every 4 seconds. So my frequency would be, okay, it would be 10 revolutions divided by 4 seconds, which would come out to be 2.5 hertz. But again, the idea is like, don't memorize it. Like, think about it, understand it. It's called frequency because we're talking about how frequent something occurs. The second one, period. Okay, period is a capital T. Why is it a capital T? Because it's a special time. Currently, right now, it is what time? It's second period. So that this is a specific time during the day. So that if we're talking about the period of something moving in a circle, it's a specific time. It's the time that it takes to go around a circle. So if you think about this, so like, oh, well, if it makes 10 revolutions in 4 seconds, the time that it takes to go around once would be 4 seconds divided by those 10 revolutions. So, 0.4 seconds per revolution. So that would be the period, okay? All right, linear speed. So if I draw my picture, so hey, look, I got something moving around a circle, okay? If I'm moving around a circle at a constant speed, and lots of the problems will have that, where you're moving at a constant speed. If you're moving around the circle at a constant speed, well, how do you find linear speed? Well, if something's moving at a constant speed, you just use v equals d over t. But hey, what is the d around a circle called? Oh yeah, that's the circumference. And in case you don't remember how to find the circumference of a circle, look, it's right there on the equation sheet. Hooray, circumference. But that is 2 pi r, and then divided by the time that it takes to go around once, which is the period. So linear speed is that. And then the other kind of just basic thing, make sure you guys understand, is actually a couple of things, is that, hey, if you are moving in a circle at a constant speed, you definitely are accelerating. Because remember, to accelerate, you have to change your velocity. So and velocity is speed plus direction. Even though my speed isn't changing, my direction is changing. Therefore, I'm accelerating. Okay, so that is there. Also, if you think about like your stomach being a good accelerometer, think about going to Great America or amusement park. Anytime you feel that feeling in your stomach, why do you feel that? Because you are accelerating. Ka-chung, 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 ka-chung. You go down the roller coaster. On the way down, you're speeding up. You feel it in your stomach. At the bottom, you feel it in your stomach because you're slowing down. If you ride one of the spin and puke rides, I don't really like those. If you ride a spin and puke ride, you feel it the whole time. Not because you're speeding up or slowing down, because you're changing your direction the whole time. You are accelerating. Okay, so that's that. And then just keep in mind, guys, that with lots of things, the reason it happens is inertia. This whole unit is just really just the second unit again. But if you guys should have done this, there's a demo where you had the paper plate puzzler, so you have a marble rolling around the edge. Well, when it gets right here, it moves straight. Why does it move straight? Because there's no outside force acting on it. There's no outside force acting on it. An object in motion stays in motion along a straight line. Boom, tangent to the circle. Okay. All right. I think that's good for an intro. Bye, kids.